Section 8.3, the graphs of sinusoidal functions. So we're going to look at the graphs of these repeating functions and see what they look like. So in this one, we're going to graph the vertical position of this pointer as a function of the degrees of rotation as we spin it clockwise twice. Okay, so right here when we start off at 0 degrees, the vertical position is 2. Then as we go all the way, this would be 90 degrees, and 90 would be halfway to 180. We can see that the vertical position is 0. Now when we go all the way to 180, we can see we have a vertical position of 2. Then when we go another 90 degrees, so 180 plus 90, which is 270, halfway in between, we can see that we have a vertical position of 4. Okay. And now when we come back to 360, we have that vertical position of 2. As I said, we're going to go around twice though, so another 90 degrees, 360 plus 90 is 450. So is that 450? I can see that I have a vertical position of 0. And then we'll go another 90 degrees. I have a vertical position of 2. Another 90 degrees, I'm up at 4. And then finally, all the way around twice, I'm back to my vertical position of 2. So if we look at this graph, it looks like the graphs we've seen before. A sinusoidal function. And here's a little thing that to remember, that here's an x and y. To remember how sine and cos look, I remember that sine looks like an S, so it starts at 0 and then goes up to its amplitude, whereas cos looks like a C, kind of an upside down C. It starts at its amplitude and then goes down. That's how I remember. So you can see this is kind of like a sine function, or actually kind of like a cos function. It's been shifted a bit, but it has that same pattern. And let's look at the range. So domain is x, its range here. Y is always greater than or equal to 0, but less than or equal to 4. It just goes between the values of 0 and 4, 0 and 4. But it can be any number between those. We graphed its domain between 0 and 720. It would continue on for a while though. Okay. Students in Simone's graduating class went on an exchange trip to China. When they were there, they rode the Star of Nanchang, one of the world's tallest Ferris wheels. She graphed, because she must have really liked math, so while on a Ferris wheel, she graphed the function. So when we say sinusoidal function, any function who has the same shape as y equals sine of x. So here's what it looks like. So how can you tell from a graph that the lowest point of the Ferris wheel is 2 meters off the ground? Well, here we started when x was 0, the height was 2, and it went up. Here the height was 120, 160, 120. So that makes sense, right? In a Ferris wheel, you start at the bottom, you go up to some maximum height, then you come back down, and you go around, and around, and around, and around, and around, and around. Maybe not that many times, or that fast. But you can see that the value never gets lower than 2. So that makes sense, right? The Ferris wheel would be 2 meters off the ground. Determining the maximum value, what is the height? So the maximum value happens right here. That maximum value is 160 meters. So that means that the Ferris wheel is 160 meters off the ground. Determine the range. So the range is between 2 and 160. Between 2 and 160. That means that the actual diameter, if this is at 2 and that's at 160, that diameter of that Ferris wheel is 158 meters. So if we can find that diameter, I'm sure we could find the radius and some other information. Determine the amplitude. Now, amplitude was defined as if we took some midline, and then if we took the amplitude is the distance either to the max or the min. And this is just a rough sketch. I'm not saying it's right in the middle. So in other words, that would be half of the range, or that radius. So if we just took 158 and divided that by 2, that would give us our amplitude. So our amplitude of 79 meters, and that's our radius. Okay, and this again was our diameter. Running out of space. Okay. So here's the graph again. Determine the equation of the midline. What does this value represent? Well, we knew that our amplitude was 79. So we know we have to go 79 units up, and from the base we go up 79 and then another 79 to get here. So if we just went 2 plus 79, we would get 81. That would be the equation of the midline right there. Okay, and then 81 plus another 79 should give us 160, which it does. So that's a good little check. What does that represent? That midline means that that Ferris wheel, that is exactly the center of the Ferris wheel, is 81 meters off the ground. Determine the period of the graph. So the period of the graph is how long it takes to go from one position all the way back to that same position. And it looks like it's 30 minutes. Okay, I also could have started from this position right here. So to go from 160 back to 160, so from the top of the Ferris wheel all the way back to the top, I started at 15 minutes, I ended at 45 minutes. That means that it's 30 minutes. Okay, what length of time is needed for this to make one full revolution? It's the same question. In order to go all the way around once, so you start somewhere on the Ferris wheel, probably the bottom, and go all the way around once. So I start at 2 meters, go all the way up, then go all the way back down. It takes 30 minutes. How long does it take to get from the top to the bottom? Well, that's going to be half of that. That's going to be 15 minutes. According to this graph, you go around the Ferris wheel twice, or that's how long Simone did. Okay. Here is another graph, some graph, and it says we have to describe this by determining its range, the equation of the midline, amplitude, and period. So let's look at the range. It looks like we go from -3 all the way up to 7. From -3 to 7, well, that is a range of 10. So its diameter is 10. Half of that is 5. So to find the midline, we have to add 5 to -3. So the midline would be at 2. This is a x equals line because it is a horizontal line. So the equation of its midline is x equals 2. So just to check, if we add another 5 onto that, do we get to 7? Yes. Okay, its amplitude is 5 because remember that's the midline to the max or the min. There's a difference of 5. Its period, I think I need to get rid of some of my marks here. So the period, whoops, I'll just do it this way. Its period is defined as going from one position and then getting all the way back to that same position. We could take it from an amplitude to another amplitude. I want to take it from some good points. There's a point. When's the next time I get to that exact point? It looks like it's 1, 2, 3 units, and it looks like each unit is worth 60, right? Because 121, yeah, 60, 120, another 60. It's going to be 180. Yep. So it looks like its period is 180 degrees. It looks like if you add 180, you get to the next point. The only reason I chose this point is because it was right on a grid line. And so I could count exactly how many grids, and then looking at the scale, I could tell what that was. Okay, now here's interesting. Sketch the graph of a sinusoidal function which has these characteristics. The domain is between 0 and 360. So that means that my x values, I start at 0 and I go to 360. The range is between -5 and +9. Okay, so I already see that I need to have a little bit better here. let's see, -4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. So that is going to be my range. Okay, what else do we know? Its period is 120, so it repeats itself every 120, and the y-intercept is 2. So I'm going to start my graph at 2. The next thing I need to do is I need to do a nice scale along here. I think if I do 60s, I'll be able to do both 120 and 360. So let's see, 60 and 60s, 120, 120 and 60. I'm going to pause and just finish the scale up. Okay, so it said it's going to repeat itself every 120. So I know if it started at the point 2, it's going to be back at the point 2 again, every 120. So another 120 is going to be there, and another 120 is going to be there. So I know that those are going to repeat themselves. So now I need to think about how the graph of a sine function works. And let's just look back up here. So we start, then we go up, down, and up. And there can be more than one answer here as well. So we have to go, oh, wait a second. First of all, we need to find that midline, right? And because I don't know if 2 is at the midline. Oh, I think it is actually, because 5 plus 2 is 7 and 9. So we have to decide what's halfway in between here. It's going to go to its maximum. Then here it's going to go to its minimum. Oh, I don't think I did that right, because it's not going to repeat. That's not quite a repetition. That's half a repetition. I think I need to go half as many times. Okay, let's take back those 2 points. I think I'm going to have to go up, middle, down, because now I've done one complete period in 120. I'm just going to follow the same pattern now. I go to my maximum, I do my amplitude, back to my midline, back down, back to where I started. So I repeat it, okay, and then back up, middle, repeat it. So just a couple things to summarize. Sinusoidal functions can be used as models to solve problems that involve repeating or periodic behavior. So those of you taking physics, you should know that periodic behavior, that repetition, things like a pendulum or a swing are repetitious. Functions whose graphs have the same shape and characteristics as the sine function are called sinusoidal functions. You can determine the characteristics of the function from its graph. Period is a horizontal distance between consecutive maximum and min values, or consecutive maximums or consecutive minimums. It's also twice the horizontal distance between a max and a min and the next max and the next min. So the other thing you can do is you can look at a graph, and if you have a max and a min, if you take that distance, the distance between a max and a min, if you double that, that'll give you your period. Okay, but really your period is between a max and a max, but that's twice as much. Okay, the equation of the midline is the average of the max and the min. So if you take the maximum, the minimum, and you add them up and divide by 2, you get that midline. To find the amplitude is the positive vertical distance between the midline and either the max or min. It's also half of the vertical distance between the max and the min. So if you take the maximum, you subtract the minimum and divide by 2, it'll give you your amplitude. Just a couple other things to remind you, some visuals, period, amplitude, midline, max, and min.